Okay, so in our last tutorial we talked about how to use Tableau to create symbol and choropleth maps for data visualizations. Choropleth maps and symbol maps are both excellent at finding geographical relationships in quantitative data, even if they're a little bit limited and present viewers with some problems, particularly occlusion problems. In this tutorial, we'll go a step further and look at how to create a density or heat map in Tableau, as well as origin path maps. Heat maps are a little bit like symbol maps and a little bit like choropleth maps, and they really serve to highlight spatial clustering and geographical relationships in large data sets. They're also more or less by their very nature restricted to highlighting a single dimension, so they're pretty easy to read, and they avoid some of the occlusion problems which plague normal symbol maps. After we've made our heat map, we'll also look at how to add a data layer using census data, which comes prepackaged in Tableau, to look for some demographic relationships between the data. Yeah, so let's get started. Here I am in Tableau, and I am going to use a data set from the National UFO Reporting Center. It is a humongous data set and very up to date. I think the most recent entries were added mid-November, and it goes all the way back to the 1960s. So there are tens of thousands, I think over 100,000 different lines in this data set. And if we take a look at it, it's mostly just there's some geographical data here, city and state. It shows the shape of the apparent apparition, how long it lasted, and a few sentences maybe describing what each person saw. So we have a date posted when the data was entered, into the form, a date of when it was apparently observed, and this is exactly the sort of data set which is made for heat maps. Let's go to sheet 1. If we pull our state and city information in Tableau, man, we see that there are about 100,000 distinct little dots here that are going to be very, very, very difficult to tell apart. And in a normal visualization, you would have to zoom in quite a bit to see anything, any spatial clusterings at all. I guess we could lower the size. That's a little bit better. But in a symbol map, we're limited. There's a lot of occlusion problems. So let's make this instead a density map. There we go. So in a density map, you see this kind of colored haze that comes over things that kind of highlights hot spots in the data where there were more or less sightings. I can control the color palette here. I'm going to go green for little green men. You can control the intensity, so bam. And I'm also going to change the size. It's kind of clouding my map a little bit more than I want it to. There we go. I'll do a different background map, and we'll do dark. And now that really pops. Okay, so I also want to filter this data by year because that's a whole lot of little dots. Looks like our maps has chicken pox. So I can go, whoa, I'm not sure what happened there. Go to date, go to pages, filter by year. Okay, so these are null. I'm going to exclude null values. You see 1905, so it goes back a long way. Let's filter out all the years before, say, 1960. Sorry that you have to watch this. There we go. And I can scroll through the data. Let's go forward. 1998. You can kind of see how clusters develop and fade with time. It's more or less stays pretty steady as to where these clusters are showing up. You'll also see this scary little indicator down here from 12K unknown. That means there are 12,000 locations that Tableau is not able to recognize. This is sadly inevitable in large data sets like this. Some locations are towns that are simply too small for Tableau to know about, and some are not really place names at all. There is, for example, in this data set, a not sure in Connecticut, which sounds a little bit like a Sleepless in Seattle sequel. In this case, I'm just going to filter them out of my display so this pesky indicator goes away. Now, because this is a map of the United States, I can add data layers if I wish. I have a nagging suspicion just from looking at the map that there are very strong correlations between the population of an area and the number of UFO sightings it produces. Plenty of heat maps are, after all, really just population maps. If I go into map layers, choose population, so I'm going to go, map layers. I'm going to go data layer. I'm going to go population. Okay, so that's population by state, which is not super helpful. I'm going to go by census tract, which is the highest level of granularity that Tableau offers. And we'll do a blue-green. It doesn't show up well, and it's a bit laggy at this level of detail and with such a large data set, so I'll remove it. But if you look at things in general, it confirms my suspicion that the higher population areas have larger number of UFO reports. So I'm going to remove this. There we go. Big cities, large urban areas see lots of UFOs. Also, you can see kind of descriptions of the different apparitions here, which are kind of, some of them are kind of funny to read. I will say that I think a scatter plot would be more useful if I wish to precisely quantify the correlation between the population of an area and UFO sightings, but this is a fairly painless way of adding a data dimension by just adding a data layer using the maps feature. Now, there may be occasions when I want to create a different kind of map in Tableau altogether. I may want to plot movement through space. So I can make an origin-destination map to help me do this, and this is the way it's done. So here I'm using a data set from Tableau, and it's only meant to give you an idea of the kind of things that are possible. I'm following a Tableau instructional article pretty closely, and also imitating a dashboard that I saw, a public dashboard that I saw on Tableau.com. So just to let you know that I didn't actually go out and find this data on my own. It was recommended to me, and I'm following instructions that I got on Tableau.com. So credit where credit's due. So here I'm going to open my Paris metro data. It's a data set of the Paris railway system, and it's composed of 5 columns. A line group here, which acts as a kind of discrete identifier, train line 1, train line 2, etc. Point order for the stops, so it shows in what order it arrives at each one of these locations, marked by latitude and longitude, and how many people use it. I think this is in the course of a month. So let's get started. First, I'm going to drag latitude and longitude onto my sheet. And there you see it. We have a map of Paris. It knows where I am. And I'm going to change my line group right here. It shows up as a quantitative measurement, but it's not really. It's a discrete identifier. So each number in this group stands for acts as a name, essentially. So I'm going to change it to discrete, and I'm going to convert it to a dimension instead of a measure. So here I'm going to drag it up into dimensions, to detail. I'm going to change the type in the marks drop-down box to lines. So here, let's zoom in and see what we're looking at. point order, this thing right here, is also a dimension. It's not a measure. The point order just says stop 1, stop 2, stop 3, stop 4. So I'm going to move it up here and also move it into detail. And whoa, it's all over the place. So let's see what's going on. So it's showing as discrete. I'm going to set the data type as continuous. I'm going to drag it here into path. So there, we have something that looks a little bit like a map. Now I think point order would also be, no, not point order, line group. We should sort it by color so we can see each distinct Paris metro line. And that looks pretty nice, doesn't it? Now, if I scroll over each of the line, I can see the stations, the point order. I have some details about the each railway line, where each point is on that railway line. So it looks like I've done a pretty good job here, but I may want to make it pop a little bit more. I may want to show exactly where those points are so that they're not just absorbed here into the line. So in order to do that, I'm going to use the dual axis tool in Tableau that we've seen before. I'm going to drag longitude up here, and now we have two maps here side by side. I'm going to take this second longitudinal map, I'm going to change the type from line to automatic, and now we have a bunch of different dots, a bunch of different colored dots that show where all the railway stops are. I may want to take my quantitative variable here now, and I want to add it to size. So size encodes it, so I can see which stops are most frequented, which stops get the most traffic. Okay, so that's pretty cool. And in order to combine the two views, I'm going to go to dual axis. I may want to make the size a little bit bigger of the dots, and that's a pretty cool map. I can see where all the train lines run, how many people get on at each stop, where the stops are. I can, if I wish, I can edit the color, give it a little border to help them pop a little bit more. And yeah, that is a nice looking map. Again, I want to thank Tableau Help for this. I just followed their walkthrough here. There's a walkthrough for creating exactly this kind of visualization on their website using this data, and I'll link it in the show notes. But this is a good example of a type of visualization that's a little bit out of the ordinary that you can create in Tableau. So, thanks for watching.